In our previous video, we discussed the key skills in data science and used a common Venn diagram to explain these classic abilities. But what if we focus on the most frequently used skills by data scientists? The answer to this question can be found by making some adjustment to the previous video and understanding the process of data science. My name is Lorindo Benjamin. I'm a data engineer and software developer. Welcome to our new tutorial. Previously, we mentioned that data science helps transform statistics into machine learning. We also highlight that data science assists business in developing software to address business tasks. This is known as software development. It is worth noting that both of types of data science heavily rely on code. They are distinct. So let's break down the Venn diagram into two sides and name each section. On the left, we have code for data analysis, and on the right, we have software and data engineering. Why are this separation useful for understanding these skills? It is also precisely defines our syllabus focus here in our tutorial. We emphasize the left side of the data science diagram. The domain knowledge will be specific to the industry you work in. However, what remains common are the data analysis techniques, statistical methods, and how we use code to transaction them into machine learning. Now, let's dive into the data science process. The first step of the data science process is data collection and storage. These steps involve capturing information, ensuring its quality, and storing it in accessible locations such as a database. Suppose we want to predict and identify a fraudulent transaction. Before anything else, we need to collect data on past transactions. We gather usernames, credit history, and other various data. But most importantly, we must also identify which of these past transactions were fraudulent. These help us learn to recognize patterns. After all, if we can't find which transactions were fraudulent in the past, how can we expect to make accurate predictions in the future? Next, data transformation for modeling. In this step, we optimize our data for the specific project we're working on and select relevant features or points of interest. On this step, we might combine or manipulate transactions from multiple data sets, filter or less important items, or adjust the data structure to make it more usable for analysis. At this point, we are ready to identify fraudulent transactions using a statistical model. Statistical and predictive analysis. This is the step where the magic happens. It is the art of the data science. Here we build models or implement algorithms that can uncover patterns in our data. For our scenario, we'll train a model to identify key indicators of fraudulent transactions. We use a variety of statistical and analytical models to help us identify and add up these patterns. Next, we have model evaluation. Here we test how well our model is performing, often represent results in their visualization. You might wonder which of our models is most effective in identifying fraudulent transactions. Well, we'll explore this further, but suffice to say that model evaluation is crucial, especially for business leaders. And finally, we are ready to share information with the business. This could involve sharing dashboards and reports with business users or unlocking our models in an automated process. Either way, this information provides real-time insights, identifying risky transactions. Remember that while these steps are typically described in order, the data science process is often cyclical. We may need to revisit early steps to improve our work, the data we've collected, or the models we've built before arriving at a final selection.